Alright, Swifter, it's Prof G, and we're going to be parsing JSON data in Swift using Codable. We're going to create a subclass of our weather location class, and we're going to create custom structs to parse complex nested JSON. Let's giddy up. Now our app can get data, good job, but right now it's just printing a big blob of output to the console. We haven't put any of this data in the app itself. There's also way more data than we'll be using in our app. So what we'll be learning in this video is how to parse or filter out and extract the elements of this data that we need. And this data is formatted as JSON. So we're going to learn how to parse JSON formatted data. Specifically, we're going to extract Timezone, which is up here, the current temperature, which is the value for temp, and that's inside this guy here named current. And we're also going to go into current and then into weather, and we'll get two more values. One for description, which describes the current weather at the location, and the other icon, which is a code for the kind of icon the app should show to depict the appropriate weather. And while we're learning how to parse JSON data, we're also going to be learning about subclassing. Now, a subclass is a class that's based on another class. It inherits everything from its parent class. Parent classes are sometimes called superclasses. But in addition to all that superclass goodness, the subclass also contains its own stuff, additional properties and methods. Now, we've already been subclassing. Whenever we've created a Cocoa Touch class as our starting class, and we've done this with UI View Controller, UI Table View Controller, UI Table View Cell, and UI Page View Controller, and then we added our own stuff on top of it, we're taking an Apple-provided superclass, and we're creating our own subclass, where we're adding our own stuff inside of all of Apple's goodness. Now, sometimes the phrase subclass can be confusing, because sub normally means less, but a subclass typically has more methods or properties. Now, we're going to be subclassing our weather location class. The reason for this is that we want to keep weather location to save the coordinates, the latitude and longitude plus the place name for our device. This guy is just right, Goldilocks for saving and loading. But now that we're getting weather data, we're going to be getting lots more data. And this weather data is stuff that we don't want to save to the device, since the weather may change every time we swipe left or right. Weather is constantly fluctuating. So we're going to get the weather data each time we update Location Detail View Controller. So we'll keep weather location as the superclass that we save, but we'll create an expanded subclass called WeatherDetail. Now, a subclass is super easy to create. We just follow the class name with a colon and the superclass name. That's it. Then we can put in all of our subclass stuff below. So we're going to move our getData method that used URL session to access dark sky from our weather location to our new WeatherDetail subclass. And that new subclass is also going to include all of the extra data structures to hold the weather information for us to display in our app, and the code needed to parse out that big wad of JSON that we got back from dark sky. Now, we also have a few options when creating an instance of a subclass from an instance of a superclass, but for now, we'll just use this one. We'll take the same initializer that's part of the superclass, but we'll call it using the subclass's class name, the type, and we'll pass in the parameters that the initializer needs. And we can do that because WeatherDetail is a subclass of weather location. It inherits all the weather location stuff, including this initializer over here. Let's do it. So back in Xcode, I'm going to create WeatherDetail below weather location. So I'll right-click on weather location, select new file. It's a Swift file. We're not subclassing one of Apple's Cocoa Touch classes. We are subclassing one of our own classes. So click next, name it uppercase WeatherDetail, click create. And we'll declare the class like we've done all others before it. Class WeatherDetail, which is the class name, but here comes the subclass goodness. We follow this by a colon, and then the name of the superclass of weather location. Open and close curlies, and this means create the WeatherDetail class so that it's got all of the stuff inside of the weather location class, the weather location blueprint, plus anything else we add below. Now, since weather location is just going to focus on holding the three values that we save and load, we'll cut out the stuff that accesses the weather data and move that over to WeatherDetail. So click weather location, highlight the entire getData function, but make sure that you leave the closing class curly, cut it out with a Command X, return to WeatherDetail, and paste it in with a Command V just before the WeatherDetail close curly. Now that we've got WeatherDetail set up, let's return to Location Detail View Controller and make sure that now we call the getData method from WeatherDetail and not from WeatherLocation. So let's replace our class-wide property of WeatherLocation with WeatherDetail. So name lower camel case WeatherDetail of type upper camel case WeatherDetail. And so we continue to declare it but not initialize it. And this will remain an implicitly unwrapped optional with the exclamation point at the end. And well, what do we do about weather location? Well, since we only use it inside of update user interface, I'll just add a let in front of weather location where I get the values from page view controller's weather locations array. And then just below this, we can initialize our new class property of WeatherDetail like this. WeatherDetail equals upper camel case, WeatherDetail open parens. And now check out what we're looking at. We see a WeatherDetail initializer with 3 parameters, but we didn't create an initializer for WeatherDetail. Where did this come from? We inherited it from WeatherLocation, the superclass. So it's that class's initializer. We can create a new WeatherDetail by passing in the same 3 values. So press return to accept that, and then we'll leverage the weather location we created just above this by saying name is weatherlocation.name, latitude is weatherlocation.latitude, and longitude is weatherlocation.longitude. And then down here, let's also set placelabel.text equal to weatherdetail.name instead of weatherlocation.name. And down here, instead of calling weatherLocationGetData, it's weatherdetail.getData. So if we scroll down, we don't see any errors in red. So now you can build and run to make sure that everything works. That means that we have successfully created a subclass of weatherlocation called weatherdetail. We've moved over getData. We're able to call it. Our data shows up. Nothing else changes in the executing app. Now let's get to parsing that JSON. So if we look at the web output for OpenWeather, I'll highlight the values we want. We first want to go on this very first level time zone. Now we won't use that in this video, but eventually we'll use this when we convert the current time to the time at that particular weather location. Then we'll need to go inside this value current. And you see how nested inside of here there are other values? Well, we want a few values in here. We want DT. It looks like a very large integer. Believe it or not, this is actually a date and time as one value. In a future video, we'll cover how to put this in a format that a human can understand, but we'll definitely need this, so we'll get it now. And also inside of current is temp. That's the current temperature at this location. And we also want some values that are inside of weather. Now, weather is inside of current. So you see how we go from current to weather, and then weather is an array. You see the square brackets? Now there's only one element in here, but we're going to want to go into that very first element of this array. That would be element number 0, and we want to grab description, which is a description of the current weather, and icon, which is that code, which will tell us what image we should use for the current weather. So how do we parse or extract those values? Let's see. So as we've been saying, this data is in the JSON format. Now, JSON stands for JavaScript Object Notation. It's the most popular format used by APIs. It's an open cross-platform data standard. It's used everywhere. And JSON organizes data in key value pairs. These are sometimes referred to as name value pairs or attribute value pairs. The key is the identifying string enclosed in quotes, and you can consider the key to be the name of the data or value that comes after the colon. Now the values can be most common data types. They can contain text, numbers, booleans, raw data, or even other nested key value pairs, as well as arrays. Now we need to turn subsets of this JSON over here into Swift variables, but fortunately Swift makes it super easy to turn JSON into an object or a struct. All we need to do is to create a struct or a class that conforms to Codable, and that struct or class has to have the same property or variable names, same case, same spacing as the JSON keys that we're trying to match it with. And as long as the JSON is of a type that's compatible with these properties, strings to strings, numbers to numbers, we can use a decoder to automatically go through all of our JSON and pick out just the stuff that we want, assigning it into the properties of our struct or class. So let's see this in action. So this code shows how we're going to do this. First, we'll create a struct inside our WeatherDetail class. We'll call that result, and this is what will eventually hold all of the decoded JSON data from OpenWeather, and we'll make it codable. Now inside of getData, we've already returned data. It was one of those 3 values, data, response, and error. So now what we're going to do is we're going to use this line to decode the JSON into a result struct and call this lowercase result. Now Timezone is at the first level of our JSON, so we can get at it just by saying result.timezone. Now getting DT and temp is going to be a little bit trickier. Both of those are inside of this guy current. So again, the way JSON works is that a key can have a value of a single data point after the colon, or as we see here, it can have a value that is an additional set of key value pairs. That's nested JSON. So inside of current is nested JSON. The values DT, sunrise, sunset, temp, etc. But getting it isn't too tricky. Each nested set of key value pairs requires just another custom struct. Once again, with the same variable names as
as the keys. So to get to DT temp in the array weather here, we're going to create a new struct named current. That's capital current, so it's a type. Now any new structs that are used to decode nested JSON also need to conform to Codable. And this new current struct that is Codable will also contain 3 properties. DT, this is a new type for us, time interval, but it's really just a double. Temp, which is a double, and weather, which is an array of another struct which we'll create. So to get to the nested JSON, we add a new property to our result type. And again, result, we could have called it anything. So there's no key value over here in our JSON that's named result. It's just something that represents the very first level of JSON. So in our result struct, we have a property named current. That's of type capital current, which is the type for this struct that can parse out the values that we need. Then to get to the values that we want, after we've decoded the JSON, we could just say result.current.dt, result.current.temp. Now we'll round this and we'll convert it to an int because we don't want any fractional temperatures in our app. And now weather is just a bit different since it's an array. Now we know it's an array because of the square brackets. It's a little weird because it's an array of just one value. I'm not sure why the folks at OpenWeather did that, but that's okay. All that matters is that we can read the JSON format and figure out how to create data structures to parse it. So since weather is an array of nested JSON, then we need to create a new weather struct with a capital W. That's a new type. Now we want only 2 values inside, so we'll add those as properties of the weather struct. Description and icon, these are both strings. And look how we get to weather. Just like we declared a current property that was part of result, we declare a weather property that's inside of current. The only difference here is that the weather property is an array of weather because of the brackets. And then to get to the description and the icon, we say result.current.weather bracket 0 bracket dot description and result.current.weather bracket 0 bracket dot icon. See how this walks down sort of like steps? So the first level is result, the second is current, the third level is weather, but since we've got brackets, we've got to refer to this as an array. That's it.
Let's build this. So back in Xcode, open up our WeatherDetail class. Let's create that result struct right under the class definition. So we'll say struct capital result colon Codable, make it Codable, open and close curly, and inside we'll put in our first variable that we want to get. That's going to be Timezone. So we'll just say Timezone colon string. And again, you need to be 100% certain that you're spelling the variable time zone the same way that the key value time zone is spelled in your JSON. Now let's go down into our get data method, find the area where we deal with data. That's our do try catch right here. And we're going to replace this JSON serialization. I'll leave it in here now just for comparison. And remember, when testing out a new API, it's a good idea to use this line of code just to make sure that you can get data from the API. So it's good to verify that before going through the process of creating all the custom structs like we're doing right now. But eventually you'll comment this out like we just did, and you're going to replace that with JSON decoding. But right after that, we'll say let result equals try JSON decoder, open and close parens, dot decode. Select this right here. You can see that it throws, so that's why we're inside of a do catch. And then for the first parameter in here for the type, it's a syntax we've never used before, but we'll say capital result, which is the type we defined above, dot self, then tab over, and from wants data. That's going to be lowercase data, force unwrap with an exclamation point. Remember, we got our data from up here. It was being returned from our data task. Data was part of the data response error, triumvirate of possibilities that comes back from the session data task. And now right under this, instead of printing out JSON, let's go ahead and print out result. And then I'll put another print statement down here. And why don't we say this is going to be the time zone is, and in string interp, result.timezone. In fact, even better, how about the time zone for string interp self.name is string interp result.timezone. But you might say, hey, wait a second, self.name, there's no name inside of our weather detail when I look up here to where our properties are. But remember, we inherited everything from weather location, and weather location has a name which is a string. So we can refer to that because weather detail has all of the properties of weather location. Then I don't need this let JSON line anymore. I just kept that in there for reference. I'm going to delete that. I don't need it. Let's build and run and take a look at our results. Now our results are going to look a little wacky. First of all, the reason why we're seeing Africa up here is because this very first current location, I don't know if you remember this, but we append this dummy data, latitude, longitude 2020. as the very first element in our weather locations.
And apparently Google Maps tells us 2020 is someplace in Chad. And that makes sense because the time zone is Jamena, which is a city in Chad.
But then when we swipe, we see Gonzaga University and we see Georgia Tech. What's going on here? Well, behind the scenes, one of the things that iOS does is sometimes it will fetch the next thing in line as you swipe, so it's pre-fetching Georgia Tech. That's why we can see that we've got Gonzaga, which is what we're showing and we're looking at in our view controller, but we also have Georgia Tech, which is waiting in the wings. Well, instead of printing stuff out, why don't we go ahead and instead take the time zone value and show it in the date label of our view controller. Now, if we're going to do that, do you remember what we need to do with our getData call? Let's take a look over here in Local Detail View Controller in the Update User Interface, which is where we'll use the data we get from getData, and we're going to use that to update our user interface. So these lines that we have up here, date label, temperature label.text, summary label.text, we shouldn't be updating these until we're sure that we've got our data back from WeatherDetail. How can we be sure? Remember from To-Do List, our friend the escape enclosure, we'll add an escape enclosure to getData. That'll let us put some curlies after getData that says, hey, don't execute what's in the curlies until you've gotten the data, and then we can put these 4 lines in those curlies. Let's make it so. So back in WeatherDetail, in getData, we no longer will have no parameters in there. We're going to have a parameter which is a closure. We'll say completed, at escaping, open and close parens, arrow, open and close parens. Now remember, we need to put in these completed signals any place where our code should escape. So I'll copy the keyword completed, and I'll first paste it before the return statement in the fail part of the guardlet here. Make sure you've got open and close parens after it. Now, I wouldn't return any data here, but I also wouldn't be hanging inside of my getData method waiting for a completed signal. And we should only need one more. I'll put it as the last statement in this closure that we execute after the session data task. So that's just before the curly that's on top of task.resume. And again, make sure that it's completed with open and close parens. And now we can return to location detail view controller, go down into update user interface, and just backspace over the 2 parens in getData, do a shift command K just to make sure Xcode knows that we made those changes. And we indeed see that getData now has a closure after it. Press return to accept that. And for the block of code in the closure, I'm just going to highlight these 4 lines up here from date label through summary label, cut them out with a command X, and paste them in with a command V. Xcode gets a little grumpy because we don't have selfs in front of the values inside of the closure. So we'll just add self dot in front of all the class properties in the closure. And now let me ask you, can you guess what we need to do to avoid an error here? I'm going to build and run and show you an error right now, and you can take a look at the problem I'm going to have. Here's a hint. Take a look at the error that we're getting here in purple, and then pause and see if you can remember how to solve it, and then resume. Let's see what you came up with. So you can see the error says UI label.text must be used from the main thread only. Oh yeah, this is encountered when we were operating on the back thread, which is exactly what's happening. Remember, the escape enclosure says cook along in the background, and then you can perform this extra stuff when you're done. Well, the stuff in the background is in the background thread, not the main thread. The main thread is where you have to execute anything that deals with the user interface, like updating labels. So what we want to do is use dispatch_queue.main.async, put a couple of curlies in there, then take all 4 lines down here that are dealing with the user interface, put them in the main queue, and we won't get that error anymore. And so we're almost ready to put our time zone inside of our date label, but we're still running into a problem because if we type in WeatherDetail and then try to do a dot result to see if we can come up with that, hey, it's not showing up. Maybe you know why. Let's go over and take a look inside of WeatherDetail. Oh yeah, we haven't created a class property of type result. So when we use result, we declare it inside of the getData function. It's not declared as a class-wide property. Now the way that I'm going to get around this is not by declaring a result property, but I'm actually going to declare a time zone. So we'll just say var time zone, and we'll actually initialize this to an empty string. This way we won't have to worry about creating an initializer for this class. And then if we scroll down into our do catch, right after we get our result, we'll say self.timezone, which is the property I just created, equals result.timezone. And I'm going to get rid of this extra stuff that I was printing. I don't need that anymore. And now I can return to my location detail view controller, and we can say WeatherDetail dot, and you can do a shift command K to make sure that Xcode knows about your work as we start to type in time zone. There it is. Press return.
And don't forget, you're going to need self dot in front of WeatherDetail because that's a class-wide property.
Now let's build and run and see. Hey, it looks like we're starting to part some JSON because I see current location shows the Africa Jamaica time zone. Let's swipe. Gonzaga has the Los Angeles time zone. That's correct. Gonzaga is in Washington State. Georgia Tech on the East Coast, they're the New York time zone. San Francisco State, they're the LA time zone. And Boston College is the New York time zone. Working well. Nice job, Swifter.
So now let's finish this off by adding some more data. So let's review from the previous slide. We want to add values for DT, which is our date time value, temp, description, and icon. So we're going to have to deal with nested JSON here, since DT and temp are nested inside current, and weather is also inside of current, and it's got its own nested content, which we need to dive into in order to get the description and icon value inside. And remember, weather is also an array. See the brackets here? So this is how we'll do it. So to parse this out, we need a property named current inside of our results struct, and that is going to be of type capital letter current. Now, capital current is going to be the struct we're going to create to represent the nested JSON. And inside of that current struct, we're going to have everything you see in this level of nested JSON that we want to get at. So that includes a property for DT and another one for temp. They've got to be spelled exactly as you see them spelled in our JSON. Now, weather is also in current, but that's an array that contains additional elements that are key value pairs. In fact, it's an array, so even though it's only got one element, we need to get into the array at value 0 before we can get at those two elements that we want inside this nested JSON. See how that one element has values ID, main, description, and icon? We only want description and icon. So we'll create a weather struct 2, again, capital W weather, and then we'll add a weather property to current, and we'll make sure that we add that as an array of capital weather. Now, we don't want to have to dig through all of these layers to get at the values that we want. So what we're going to do is we're going to create class properties for all 5 of these values. And then after decoding data, we're going to assign our JSON values to the class properties this way. Result.current.dt, result.current.temp, and we'll also round this and convert it to an int since we don't want any decimal temperatures. And then we'll get properties in weather like this: result.current.weather bracket 0 bracket dot description, and result.current.weather bracket 0 bracket dot icon. Let's do it. So now let's head back into WeatherDetail.swift, and to work with nested JSON, we're going to want to add a current property to our result struct. Now that property is going to be of type current. It's going to be a special struct that we create. So let's create the struct first so that we can assign our current property inside a result to this new struct. And we'll create that just below the result structure. So we'll say struct, capital current, colon, it's codable, open and close curlies. Inside we've got 2 properties, var, dt, colon, time interval, that's a new type for us, but it's the same thing as a double. Then var temp colon double. Now we can go up here into our result struct. We'll add a new property. We'll say var lowercase current colon uppercase current. Now weather is an array of nested JSON, so we're going to need another structure for that. Struct capital weather colon it's codable open and close curlies, and we've got 2 properties in there, var description colon string and var icon colon string. Now again, make sure each of your properties is named the exact same way it's expressed in JSON. Same case as well. It is. So now we can add a weather property to our current struct. We'll say var weather colon, and then inside square brackets capital weather, because this is an array of that new struct. And now let's create class properties that are going to hold the values of our parsed JSON. So down here below Timezone, which we've already created, we'll say var current time equals 0.0. This is a time interval, but that's the same as double, so this works fine. Var temperature equals 0. Var summary equals empty string, and var daily icon equals empty string. And by initializing these to these sort of empty values here, that avoids us having to create a special initializer for this class. So now let's use these values after we've gone through our JSON decoder and put this into our class properties. And this is simple. Under Timezone, which we've already got, we'll say self.currentTime equals result.current, nested in on one level, .dt. Under that, we'll say self.temperature equals result.current.temp. But this is a double. Temperature is an int. We don't want any decimals in our temperature, so what we'll do is we'll say dot rounded right after our temp value. Look at our description and code completion. It says returns the value rounded to an integral value using schoolbook rounding. That means just round up for 0.5 or greater, round down below that. Then to convert it to an integer, we'll put int in front and wrap the whole value in parentheses. That'll work great. Then we got to get the stuff inside of the weather array, so that's self.summary equals result.current.weather, open square bracket 0, close square bracket because it's the first element in the array, dot description, and then down below that self.dailyIcon equals result.current.weather, bracket 0, bracket dot icon. Now let's finish things up in the location detail view controller. Since we got everything from JSON and we put it in properties for our class, we can now display them in the user interface, inside update user interface, inside WeatherDetail, inside of our dispatch queue. You see where we had just dashes in here to represent the temperature? Well, now we can get rid of those dashes, put in a string interp, and refer to self.weatherdetail.temperature. Down below that, we had an empty string for the summary label. Let's get rid of that empty string and replace that with self.weatherdetail.summary. Let's build and run and take a look at what we got. No errors. Build succeeded. Hammer time. And ho-ho, someplace in chat, it's 82 degrees currently. Swipe to Gonzaga. Scattered clouds. We haven't updated our image yet, but that's 70 degrees. Swipe to Georgia Tech. How are the jackets doing? 73 and light rain. San Francisco State has a few clouds, and it's a toasty 82. And I can confirm here at Boston College, it's 77 degrees, nice and toasty out. Broken clouds means just a few clouds in the sky. Excellent, Swifter. You just mastered JSON parsing. Hope you're feeling good about your skills. Keep at it.